Okay, so here is page 4. Trig identities. These are some of my favorite. So use trig identities to write each expression in terms of a single trig identity or trig function. So here, cosine squared plus secant x. So what we kind of want to do is make everything, there's no addition or subtraction I have to worry about, so let's make everything sine and cosine. So this will be cosine squared x times 1 over cosine x. Secant x is cosine x. 1 over cosine x. And then we can multiply these two out, so you get cosine squared x over cosine x. 2 cosines on top, 1 on bottom. 1 cancels out the other, leaving just cosine of x. Okay? Right here, 1 minus sine squared x times cosecant squared x. So this, we have a subtraction and we have squared, so this is going to be a Pythagorean identity. So 1 minus sine squared x is the same as cosine squared x. And then cosecant here, well, I'm going to change that. We could make this, use the Pythagorean identity for that one. I don't want to, because that'll add addition and subtraction, and we don't like that. So we'll make this 1 over sine squared x. Multiply these two together, and you get cosine squared x over sine squared x. Cosine over sine is the same as cotangent, so we'll get cotangent squared x. Okay, number 26. We have 1 over 1 plus cotangent squared x. So we have, again, addition and subtraction with a cotangent squared x. One of our Pythagorean identities is, I believe it's cosecant. Cosecant squared theta minus cotangent theta. Cotangent squared theta equals 1. And so if I add cotangent theta to both sides, I get this. So this whole thing is going to be 1 over cosecant squared theta. And then 1 over cosecant, that is the reciprocal. So 1 over makes it the reciprocal of sine squared theta. There we go. Now here we have find the exact value of the sum or difference. So I have sine of 3 pi over 4 minus 5 pi over 6. So in this case, it's sine of the difference of two angles. So we're going to do, this will be sine cos sine. Then I fill in my angles. This is 3 pi over 4, 5 pi over 6, 3 pi over 4, 5 pi over 6. And then sine has the same sign here, so that'll be a minus. So sine of 3 pi over 4, well, all the over 4s are root 2 over 2. This is in quadrant 2, and sine in quadrant 2 is positive. Cosine, all the over 6s for cosine are square root of 3 over 2. 5 pi over 6 is in quadrant 2, and so cosine is negative in quadrant 2. Minus cosine of 3 pi over 4 is, all the over 4s are root 2 over 2. This is quadrant 2, and cosine is negative there. Sine of 5 pi over 6, well, all the over 6s for sine are 1/2. In quadrant 2, sine is positive. And now we can just simplify. Square root of 2 times a negative root 3 is going to be the square root of 6 over 4. And then negative times a negative here is going to be a positive root 2. So this will be plus root 2 over 4. So we end up with root 6 plus root 2 over 4. Which sounds wrong. Quadrant 2 plus quadrant 2. Oh, subtraction. Never mind. That's right. We're good. Sorry. Now, cosine of pi over 2 plus 2 pi over 3. So here for cosine, it is cos, sine, sine. Yeah, cos, sine, sine. And we have pi over 2 plus 2 pi over 3. Not plus 2 pi over 3. These are different. And then, so that'd be a subtraction. I get pi over 2 here and 2 pi over 3 here. Cosine of pi over 2 is 0. Cosine of 2 pi over 3. So all the over 3's are 1/2. Quadrant 2 makes that a negative 1/2. Minus sine of pi over 2 is 1. And then we will have sine of 2 pi over 3 is, so sine 2 pi, all the over 3's are going to be root 3 over 2. This is in quadrant 2, so that'll be a positive for sine. And so 0 times 1/2 goes away, so we have a negative root 3 over 2. Plot polar coordinates. So we have negative 3, 2 pi over 3. So 2 pi over 3 is right here. And we want to go negative 3. So we throw the ball backwards. So 1, 2, 3. Right there, towards 5 pi over 3. Convert from polar to rectangular. So this is going to be, from polar to rectangular. So we need to figure out the x and y coordinates are here. And we can kind of draw this out real quick if we wanted to. So 5 pi over 6, so that's going to be in quadrant 2. Really, you don't even need to know that because all this does, this is the easy one. So we're going to do 4 cosine of 5 pi over 6, comma, 4 sine of 5 pi over 6. So that is the coordinates for it. Cosine of 5 pi over 6, all the over 6's are root 3 over 2. And this is in quadrant 2, so this will be a negative root 3. So 4 times negative root 3 over 2. And then all the over 6's for sine are 1/2. Quadrant 2, sine is positive and 1/2. So this becomes negative 2 root 3, 2. And there we go. And now we're going to convert from rectangular to polar, where theta is in between 0 and 2 pi. So let's see here. So this is in quadrant 4, right? Quadrant 4. Positive, negative. Quadrant 4. So what we need to do is we need to first find r. R is equal to the square root of 2 squared plus negative 4 squared. It's the Pythagorean theorem. So this 2 squared is 4 plus 16, the square root of 20. We can factor out a 4 out of that, so we get 2 square roots of 5. R is equal to 2 square roots of 5. And then our theta is equal to the inverse tangent of y over x. So negative 4 over 2. So inverse tangent of negative 2. Come back to my dying calculator. Second, inverse tangent of negative 2 is negative 1.07. Now, the problem with this is in quadrant 4, but it's negative. It's not in between 0 and 2 pi. So I need to get the quadrant 4 version of this. So I'm going to add the coterminal to get a coterminal angle. Nope, that's not the button I meant to put. Delete that out real quick. So plus 2 pi. We're going to add 2 pi to it to get theta is 5.176. So there's my r and theta. My point is going to be 2 root 5.176. Since this is a decimal, I'm pretty sure that'd be fine if you did this as a decimal approximation as well. Okay, convert from rectangular to complex polar form. So this is going to be signs, more signs and stuff. So from rectangular to polar, that means that this is A, this is B, or this is X, this is Y. Same thing, different labels. So we're going to do the same thing as we did up here. So our polar form is going to be, so we're going to do the square root. So let's see here. R is equal to the square root of negative 3 squared plus negative 5 squared. So negative 3 squared is 9, negative 5 squared is 25, so we get the square root of 34. And then we need the inverse. So this is in negative negative, so this is quadrant 3. So we need the inverse tangent. Theta is the inverse tangent of y over x, or b over a. So negative 5 over negative 3. And I put that into the calculator. So second inverse tangent of negative 5 divided by negative 3. Is that right? Yeah, negative 5 over 3. And we get theta is equal to 1.030. Now the problem with this is quadrant 1. It's less than 1.57. This is in quadrant 1. We don't want quadrant 1. We want quadrant 3. So I need to add pi to this to get to quadrant 3. And we can add pi because pi is the period of tangent. So we are going to add pi to that to get to quadrant 3, 4.17. So theta is equal to 4.172. And so to put it in polar, complex polar, we're going to write this as root 34 cosine of 4.172 plus I square root of 34 sine of 4.172. And so that's your A plus BI right there. Okay. Convert from polar to from complex to regular. This one is super. Actually, we don't need the calculator for that. These are special angles. If they're special angles, you're not going to be able to use a calculator, more than likely. So what is cosine of 3 pi over 4? Well, that's root 2 over 2. And this is in quadrant 2. Always check the quadrants. So cosine is negative in quadrant 2. Sine of 3 pi over 4 is also root 2 over 2. And this is in quadrant 2, which is positive. And so we'll have root 2, so that'll be plus. So root 2 over 2i all of that times 6, so distribute the 6, and you should get negative 3 root 2 plus 3I root 2 is usually the normal way to write that. Okay, that concludes whatever page that is, page 4. I'll see you guys on page 5.